Welcome to the DIY Honda Garage channel. The DTC P2138 specifically relates to the accelerator pedal position APPP sensor system within the 2022 Honda Civic and identifies an issue with incorrect voltage correlation between two APP sensors. The APP sensor is integral to the operation of the vehicle, as it provides the PCM, powertrain control module, with information about the position of the accelerator pedal. If the voltage levels from APP sensor A and sensor B deviate from expected parameters, the PCM registers this as an anomaly, resulting in the storage of DTC P2138. This situation can affect vehicle performance, leading to reduced engine responsiveness. Understanding the APP sensor's role, its location integrated within the accelerator pedal module, and how it communicates with the PCM is crucial for effective troubleshooting. Comprehensive diagnostics ensure not only identification of faults, but also the restoration of normal function. The accelerator pedal position APP sensor are located within the accelerator pedal module. Specifically, there are two sensors, APP sensor A and APP sensor B, which monitor the movement of the accelerator pedal and transmit their voltage level signals to the powertrain control module, PCM. The PCM is responsible for regulating various engine functions, including throttle position, based on the input from the APP sensors. A deviation in the voltage between these two sensors indicates a potential malfunction in either the sensors themselves or the wiring between them. The vehicle's ability to respond to accelerator pedal inputs, which is vital for control and safety, may be compromised. Therefore, understanding the function and location of these components is essential for effective troubleshooting of DTC P2138. Several possible causes can lead to the DTC P2138 being triggered. First, shorted wiring in the circuit between the APP sensors and the PCM may create incorrect voltage signals, resulting in the PCM sensing an abnormal correlation. The second cause could be a faulty APP sensor itself. Either APP sensor A or B may have developed a fault, contributing to erroneous voltage readings. Lastly, if the PCM has malfunctioned, it may misinterpret signals from the APP sensors, again leading to the detection of erroneous correlation. Identifying which of these causes is responsible is crucial for effective repair. Proper inspection of wiring, both visually and with diagnostic tools, along with isolation of the APP sensors themselves, is required to narrow down the issue. Drivers may experience several symptoms if DTC P2138 is present. One common symptom is erratic throttle response. The vehicle may not accelerate smoothly or as expected when pressing the accelerator pedal. This can lead to an unsafe driving experience. Additionally, the check engine light, which signals any malfunctions detected by the PCM, will likely illuminate on the dashboard. This light serves as a prompt for drivers to investigate the vehicle's health further. Drivers may also notice poor acceleration performance during driving. The vehicle may hesitate or fail to respond promptly when acceleration is requested. Each of these symptoms indicates a potential issue with the APP sensor system and should be taken seriously for the safe operation of the vehicle. The first step in troubleshooting DTC P2138 involves confirming vehicle power and testing the accelerator pedal's functionality. Begin by turning the vehicle ignition to the on mode, which powers the vehicle's electrical system without starting the engine. Next, press the accelerator pedal fully to the floor. This action allows the PCM to read the voltage signals from the APP sensors during maximum acceleration. Observing the performance at this stage is crucial, as it sets the baseline for further diagnostics. The responses noted here will help to determine if the problem lies with the APP sensors, wiring, or the PCM itself, as they provide initial perspective on the electrical circuits involved. In the second troubleshooting step, the focus is on inspecting APP sensors A and B, referred to as APS1 and APS2. Disconnect the PCM connector and the APP sensor connector, ensuring no electrical current interferes with testing. Following the procedures, perform a shorted wire inspection to examine whether there's low resistance in the circuitry between the sensors. The expectation is to measure more than 1 megaohm of resistance. If measurements indicate lower resistance, shorted wiring through the circuit could be causing incorrect voltage readings, necessitating repairs or wiring replacement. This critical step narrows down electrical integrity and ensures that all connections are appropriate before advancing to sensor testing. In this step, we focus on assessing the actual outputs from the APP sensors using a diagnostic tool known as HDS, Honda Diagnostics System. After turning the vehicle to the on mode and pressing the accelerator pedal to various positions, confirm the voltage readings for APP sensor A and B. During this inspection, the expected normal condition is that the HDS reading for APP sensor A voltage must be approximately double that of APP sensor B voltage at any given position of the accelerator pedal. If the data does not reflect normal values, this indicates an issue with the accelerator pedal module, which may need to be replaced or serviced to return to optimum functionality. This final comparison against the expected readings is vital in diagnosing the APP sensor system's performance. This troubleshooting step involves a comprehensive assessment of the APP sensor's internal circuit integrity. Before proceeding, make sure the PCM connector is still disconnected. The procedure requires testing continuity within the APP sensor itself. There should be no continuity when the sensor circuits are measured in the off position. If continuity is detected, a fault within the internal circuit of the APP sensor has been established, leading to erroneous voltage outputs to the PCM. It is vital to rectify any such internal faults either by replacing the sensor or identifying any potential manufacturing defects. Completing this procedure ensures that the APP sensor can accurately reflect its intended function to the PCM, thus maintaining operational safety and driving efficiency. In this penultimate troubleshooting step, we focus on evaluating the powertrain control module, PCM, itself, especially if all previous tests returned normal results for the other components. As the brain of vehicle operations, a faulty PCM may continue to misinterpret accurate signals from the APP sensors, leading to persistent DTC P2138 indications. Examination of the PCM involves looking for visible signs of physical damage or electrical burn marks, which could indicate failure. Utilizing necessary testing equipment can allow for a comprehensive analysis of the PCM's operational parameters. If the PCM shows abnormal readings or operational failure without any discernible faults found in previous steps, it may be concluded that the PCM itself requires repair or replacement to solve the issues relayed by the DTC. Upon completing repairs based on the preliminary diagnostic findings for DTC P2138, it is crucial to validate the effectiveness of those repairs. Begin by clearing the DTC codes from the PCM using HDS and ensure that the DTC is reset. Following this, take the vehicle for a test drive to simulate various driving conditions. Monitor the system performance, paying close attention to the throttle response and whether the check engine light reappears. If the DTC remains cleared and driving performance aligns with expected behavior, it confirms that the repairs successfully resolved the issue. Conducting this verification step ensures that the vehicle is not only operating safely, but also reaffirms that no further corrections are needed to maintain optimum vehicle performance and minimize the occurrences of DTC P2138 in the future. Preventive maintenance is vital. Regular inspections of the wiring associated with the APP sensors will help identify any signs of wear, corrosion, or physical damage that could lead to shorted circuits. It's equally important to periodically check the functionality of the APP sensors themselves, verifying proper electrical resistance and signal output to the PCM. Establishing a routine service check could catch potential issues early on, mitigating expensive repairs or unintended vehicle behavior. Consistent preventive practices ensure that the electronic systems operate as intended and enhances overall driving satisfaction. In conclusion, DTC P2138 presents a significant concern regarding the correlation of voltages from the accelerator pedal position sensors. This trouble code indicates problems either with the APP sensors or the PCM, potentially impacting vehicle throttle response and overall drivability. Thorough diagnostics protecting the integrity of these key components are necessary to successfully identify faults and restore system functionality. It involves checking connections, verifying sensors, and assessing the PCM itself. Through meticulous troubleshooting and embracing preventive maintenance habits, issues related to this DTC can be effectively managed. Understanding the function of these components ensures a safer and better driving experience. Please like and subscribe to the channel. See you next time.